What if one journey made by a handful of ancient people thousands of years ago changed the fate of every civilization that followed? Long before kingdoms, writing, or even farming, fearless humans crossed mountains, deserts, frozen landscapes, and vast coastlines into worlds no one had ever seen. Their incredible migration reshaped our DNA, transformed cultures, and determined where humanity would thrive or disappear forever. Today we'll uncover the forgotten journey that made us who we are. Before we begin, if you enjoy ancient mysteries, lost civilizations, and the hidden story of humanity, please like this video, subscribe to the channel, and turn on notifications so you never miss our next adventure into the distant past. Now let's travel back to the migration that changed humanity forever. A cold wind sweeps across an endless grassland where no cities stand, no roads divide the earth, and no written memory exists to preserve the lives unfolding beneath the wide sky. Herds of wild horses move across the horizon. Woolly mammoths carve silent paths through patches of snow. Rivers swollen by melting ice in one season and frozen solid in the next shape a landscape that appears timeless, but is changing in ways no human eye can fully understand. Somewhere beyond those distant hills, a handful of people pause to watch the movement of animals that have become the rhythm of their existence. They do not know it, but their descendants will eventually reach nearly every continent on Earth. The journey that begins in worlds like this will reshape the future of humanity forever. Before we go deeper, take a moment to like the video and subscribe if this is the kind of history and mystery you enjoy. The remarkable part of this story is not simply that human beings spread across the planet. Countless species expand their territory whenever conditions allow. Wolves follow prey. Birds follow changing seasons. Plants ride the wind with invisible seeds. What makes the human migration different is that it transforms not only geography, but the entire destiny of a species. Every language spoken today, every civilization ever built, every scientific discovery, every work of art, and every city that now covers the landscape can ultimately trace its roots back to a series of decisions made by small groups of hunter-gatherers walking across unfamiliar ground tens of thousands of years ago. For most of human existence, there are no kingdoms, no temples, and no permanent settlements. Humanity survives in small bands that rarely number more than a few dozen individuals. They know every face within their community. They remember every reliable water source. Every season demands careful observation. A failed hunt means hunger. An unusually cold winter may mean death. Survival depends less on strength than on cooperation, memory, and an extraordinary ability to adapt. Modern humans. Homo sapiens emerge in Africa more than 300,000 years ago according to the oldest widely accepted fossil evidence. Yet this beginning does not resemble the neat starting point often imagined in simplified histories. Africa itself is immense, containing forests, coastlines, mountains, open savannas, wetlands, and deserts that shift dramatically over thousands of years. Human populations are scattered across these diverse environments, developing different traditions, technologies, and ways of surviving long before any successful expansion beyond the continent begins. The Africa these early humans inhabit is not static. Climate repeatedly swings between wetter and drier periods, as subtle changes in Earth's orbit alter rainfall patterns over enormous spans of time. Grasslands expand before shrinking again. Lakes appear where dry plains once stretched only to disappear centuries later. Rivers change course. Entire ecosystems advance and retreat. What seems permanent to one generation may vanish long before the lives of their distant descendants. These environmental shifts quietly shape human history. During wetter periods, green corridors connect regions that are normally separated by harsh deserts. Animals spread into new territory, followed closely by the people who depend upon them. During drier periods, those same pathways disappear, isolating communities for thousands of years. The landscape itself becomes both bridge and barrier, opening opportunities before abruptly closing them again. Scholars still debate exactly how these climatic cycles influence early migration. The evidence remains incomplete because wind, water, vegetation, and time erase countless traces of ancient lives. Campsites disappear beneath sediment. Wooden tools decay. Fires leave only faint stains in the soil. Entire generations pass without leaving fossils. Archaeologists often reconstruct vast chapters of prehistory from scattered fragments. A broken stone blade here, an ancient footprint there, a few pieces of charcoal preserved beneath layers of earth. Yet those fragments reveal something extraordinary. Even before humanity begins its great migration, people display remarkable flexibility. They fish along coastlines. They hunt large mammals across open plains. They gather roots, fruits, shellfish, and edible plants. They manufacture increasingly sophisticated stone tools that reflect planning rather than simple instinct. They care for children over many years, allowing knowledge to accumulate across generations in ways that few other species achieve. Knowledge itself becomes one of humanity's greatest survival tools. Fire offers warmth, protection, and new ways to prepare food. Stone blades become sharper and more specialized. Wooden spears grow more carefully balanced. Simple containers allow resources to be carried over longer distances. None of these innovations appear overnight. Instead, they accumulate gradually through countless observations made by people whose names are forever lost. Perhaps even more important is communication. Language almost certainly exists long before written history, although no direct evidence survives. Complex speech allows hunting strategies to become more sophisticated. It permits stories about dangerous animals, distant water sources, changing seasons, and unfamiliar landscapes to spread through communities. Experience no longer dies entirely with the individual. It begins to outlive generations. The social world of these early humans also differs from the image often portrayed in popular imagination. Life is dangerous, but it is rarely a constant struggle of endless violence. Cooperation frequently offers greater rewards than conflict. Sharing food reduces risk when hunting fails. Caring for injured companions increases the group's long-term chances of survival. Older members preserve memories of landscapes encountered decades earlier, knowledge that may become invaluable when climates change once again. Meanwhile, the world beyond Africa is far from empty. Across Europe and Western Asia, Neanderthals have already adapted to colder climates over hundreds of thousands of years. Farther east, Denisovans occupy regions that scientists are only beginning to understand through astonishing discoveries extracted from ancient DNA. Other human relatives may still survive in isolated places, their existence now known only through scattered fossils and mysterious genetic traces. The Earth at this time is a mosaic of different human populations rather than a world occupied by a single species. Their territories overlap only occasionally. Mountains, deserts, glaciers, and immense distances keep many groups separated for thousands of generations. What survives in the record suggests that these populations evolve along different paths while sharing distant common ancestors. Ice sheets also dominate enormous portions of the northern hemisphere. Vast glaciers lock away tremendous quantities of water, lowering sea levels by more than 100 meters compared with today. Coastlines extend far beyond their modern limits. Islands are connected to continents. Plains stretch across areas now hidden beneath oceans. Many of the landscapes where crucial chapters of human migration unfold will later disappear beneath rising seas, making their archaeological record frustratingly incomplete. No single explanation fully accounts for why one branch of humanity eventually succeeds in spreading across nearly the entire planet while others do not. Intelligence alone cannot explain it. Strength cannot explain it. Luck almost certainly plays a role, as do climate geography, cooperation technology, and countless unpredictable events that leave no trace in the archaeological record. For now, however, none of those future achievements are visible. The people standing beside the rivers of ancient Africa are not thinking about continents they have never imagined. They're watching clouds gather above distant hills, reading the tracks left by animals in damp earth, listening to the wind and making choices that seem ordinary within the rhythm of everyday survival. Yet hidden within those ordinary decisions lies the beginning of one of the greatest transformations in the history of life on Earth. Step by careful step, generation after generation, humanity is approaching the moment when it will begin leaving its oldest homeland, carrying with it the knowledge, resilience, and curiosity that will ultimately reshape the world itself. The first footsteps beyond an ancient homeland are almost impossible to identify. No single family reaches a boundary and declares that they are leaving Africa forever. No ceremony marks the beginning of humanity's greatest migration. Instead, the movement unfolds so gradually that generations pass without realizing they are participating in one of history's defining transformations. A valley that once seemed distant becomes familiar. A seasonal hunting ground becomes a place where children are born. Another river lies just beyond the horizon, then another. Over centuries, small advances accumulate until people find themselves living in landscapes no ancestor had ever known. This slow expansion is one reason the story remains so difficult to reconstruct. Modern maps encourage the illusion that continents are clearly separated and national borders are fixed. The late Pleistocene world bears little resemblance to this familiar picture. Sea levels are dramatically lower because enormous ice sheets lock away vast quantities of water. Coastlines extend far beyond their modern limits. The Sinai Peninsula offers a corridor into Southwest Asia during favourable periods. At other times, the narrow waters of the Bab el-Mandeb Strait shrink enough to reduce one of the greatest natural barriers between Africa and Arabia. Neither route is permanently open nor permanently closed. Climate continually alters the possibilities. For decades, scholars imagined a single dramatic exodus that carried modern humans into the wider world around 60,000 years ago. The evidence now paints a more complicated picture. Fossils discovered in the Levant suggest that earlier groups leave Africa much sooner, perhaps as early as 120,000 years ago during warmer and wetter intervals. Stone tools resembling African technologies appear outside the continent. Human remains found in caves hint at populations that spread into new territory, only to disappear again when climates shift. These early ventures seem less like permanent conquest than exploratory expansions. Favourable weather creates green landscapes where deserts later return. Herds move northward into newly productive grasslands and human hunters follow them. Then rainfall weakens, lakes shrink, vegetation retreats. Once open corridors become harsh barriers once more. Some communities withdraw, others vanish entirely. The evidence remains incomplete, but what survives suggests that humanity makes several attempts before one migration ultimately succeeds on an unprecedented scale. Climate acts less as a simple obstacle than as an ever-changing architect of opportunity. Africa itself experiences repeated cycles of abundance and hardship. During humid phases, the Sahara is almost unrecognizable compared with the immense desert of today. Rivers cross regions that are now barren. Permanent lakes support fish, crocodiles, hippos, and dense wildlife. Grasslands stretch across landscapes now covered by endless dunes. Archaeological discoveries reveal campsites, stone tools, and rock art in places where survival would later become nearly impossible. When arid conditions return, these green worlds collapse, water sources disappear, animal populations decline or migrate elsewhere. Human communities face increasingly difficult choices. Some adapt to shrinking resources, others move toward more reliable environments. Migration, therefore, is not necessarily driven by desperation alone. It often reflects the search for stability in a climate that refuses to remain stable for long. Population growth may also play a quiet but important role. Even small increases in the number of people can gradually place pressure on familiar hunting territories. A successful community raises more children. Those children eventually become adults with families of their own. Nearby resources that once seemed abundant must now support additional mouths. Rather than conflict becoming inevitable, younger groups may simply establish themselves farther away, repeating a pattern seen among many hunter-gatherer societies throughout history. What makes Homo sapiens particularly successful is not unmatched physical power. Compared with many Ice Age predators, humans are relatively slow, lightly built and poorly equipped with natural weapons. They compensate through flexibility. They modify hunting techniques to suit different prey. They exploit coastal shellfish when large game becomes scarce. They gather edible plants overlooked by other species. They cooperate in ways that multiply individual abilities into collective strength. Fire remains one of the most valuable companions on these journeys. Beyond warmth and cooking, it transforms landscapes. Carefully managed burning encourages fresh vegetation that attracts grazing animals. Smoke discourages insects. Hardened wooden spear tips become more durable. Camps become safer after sunset. Fire allows people to occupy environments that would otherwise prove far more dangerous. The expansion beyond Africa also depends on remarkable powers of observation. Travelers learn to read clouds that signal approaching rain. They recognize seasonal migrations of birds. They understand which plants indicate underground water. They memorize mountain passes, sheltered valleys, and dependable springs. This knowledge accumulates gradually carried not in books, but in human memory. Every successful journey becomes a lesson passed to the next generation. Scholars still debate the precise importance of coastal routes during these migrations. One influential hypothesis suggests that shorelines provide reliable food sources, rich in fish, shellfish, seabirds, and marine mammals. Such environments may allow small populations to expand steadily, without relying entirely on unpredictable hunting. Unfortunately, much of the coastline that existed during the Ice Age now lies beneath the sea. Rising oceans following the last glacial maximum submerged countless ancient campsites, leaving large portions of this story permanently hidden. This loss presents one of archaeology's greatest frustrations. Entire chapters of human migration may now rest beneath dozens of meters of seawater. Stone tools, fireplaces, and temporary shelters that once overlooked broad coastal plains are concealed beneath marine sediments. Modern technology is beginning to investigate some submerged landscapes, yet the task is immense. Every new underwater discovery reminds researchers how much evidence has likely disappeared forever. Despite these uncertainties, genetics offers an extraordinary second line of evidence. Ancient DNA recovered from fossils combined with the genetic diversity of living populations reveals that all people alive today ultimately descend from African ancestors. The branching patterns within human genomes preserve echoes of ancient separations, migrations, and population bottlenecks that occurred tens of thousands of years ago. These genetic signals do not provide a complete map, but they reinforce what archaeology has long suggested. The successful expansion beyond Africa is real, complex, and far more dynamic than earlier models imagined. Perhaps the most surprising aspect is how small these founding populations appear to have been. Humanity's global expansion is not launched by massive armies or countless migrating tribes. Instead, relatively modest groups carrying limited possessions gradually establish new populations across immense distances. A few dozen individuals settling one valley eventually produced descendants who spread into neighboring regions. Over thousands of years, these modest beginnings multiply until entire continents become inhabited. No single explanation fully accounts for why one migration succeeds where earlier attempts fail. Slight improvements in climate may coincide with advances in technology. Larger social networks may increase resilience during difficult periods. Better communication may allow knowledge to spread more efficiently between neighboring groups. Fortune almost certainly influences events as well. A sequence of favorable seasons can mean the difference between survival and disappearance. As these travelers continue northward and eastward, the world ahead becomes increasingly unfamiliar. Vast mountain chains rise beyond the horizon. Dry plains stretch farther than anyone has previously experienced. New predators roam forests unlike those of Africa. More astonishing still, these migrants are approaching territories already occupied by other kinds of humans who've been adapting to Eurasian environments for hundreds of thousands of years. The greatest migration in history is no longer simply a journey across landscapes. It is becoming an encounter between different branches of humanity itself. The farther these small bands travel from their ancestral homeland, the less familiar the world becomes. The open savannas that once defined everyday life gradually give way to rugged mountain ridges, dense woodlands, rocky coastlines, and broad river valleys unlike anything their grandparents had known. Every new landscape presents unfamiliar opportunities, but it also introduces dangers that cannot be recognized at first glance. A harmless-looking plant may be poisonous. A calm river may flood without warning after distant rainfall. A sheltered valley may become a deadly trap during winter storms. Survival now depends not only on courage, but on an unmatched ability to observe, learn, and adapt faster than the environment changes around them. The Near East becomes one of the first great crossroads in this unfolding migration. Positioned between Africa, Europe, and Asia, it serves as both gateway and barrier for countless generations. Climatic shifts repeatedly transform this region. During wetter intervals, grasslands spread across areas that later become dry and inhospitable. Rivers flow more reliably, attracting animals and the people who hunt them. During colder or drier periods, many of these same landscapes become increasingly difficult to cross. Human expansion advances in pulses rather than in one uninterrupted march. Archaeological sites scattered across modern-day Israel, Jordan, Saudi Arabia, and neighbouring regions preserve fragments of this long process. Stone tools reveal technological traditions that resemble those developed in Africa, while fossil remains demonstrate that modern humans occupy parts of Southwest Asia earlier than once believed. Yet many of these early populations appear to vanish from the record. Scholars still debate exactly why. Some communities may retreat as climates deteriorate. Others may be absorbed into later migrations. Some may simply leave too little evidence to survive tens of thousands of years of erosion and geological change. As generations continue moving, they enter ecosystems that demand entirely new survival strategies. In Africa, many hunting traditions revolve around familiar prey species. Eurasia offers an astonishing diversity of animals, including giant deer with enormous antlers, steppe bison, wild horses, cave bears, woolly rhinoceroses, and mammoths. Each species behaves differently. Each requires careful observation before successful hunting becomes possible. the challenge extends beyond finding food. Temperatures across much of Eurasia fluctuate dramatically with the advancing and retreating ice sheets of the late Pleistocene. Winters become longer and harsher than anything experienced in tropical Africa. Thick clothing fashioned from animal hides grows increasingly important. Shelters become more sophisticated. Fire is no longer merely convenient. In many regions, it becomes essential for survival. Evidence suggests that human technology evolves steadily alongside these environmental pressures. Stone blades become thinner, sharper, and more specialized. Different tools emerge for cutting, meat scraping hides, carving wood, and preparing plant fibers. Bone and antler begin serving as valuable raw materials, producing needles, awls, fish hooks, and projectile points that expand the range of possible adaptations. These innovations do not appear everywhere at the same time, nor do they follow a perfectly straight line of progress. Instead, they spread gradually through learning, experimentation, and contact between neighboring groups. Social organization also becomes increasingly significant. Small bands remain the foundation of daily life, yet they are rarely completely isolated. Evidence from archaeological sites suggests that materials such as high-quality stone sometimes travel remarkable distances from their original sources. This movement implies that neighboring communities maintain connections extending far beyond a single campsite. Such networks may allow information marriage partners tools and survival knowledge to circulate across wide regions, increasing resilience during periods of environmental uncertainty. The importance of these social networks cannot be overstated. Imagine a season of severe drought or unusually heavy snowfall. A completely isolated group facing starvation has few options. A community connected to neighboring bands through long-established relationships may instead travel toward familiar allies, exchange resources, or gain access to territories that would otherwise remain closed. Cooperation becomes another form of technology invisible in the archaeological record, yet potentially as important as any stone blade. Meanwhile, the landscapes themselves continue changing. Massive glaciers covering northern Europe and parts of Asia influence weather patterns thousands of kilometers away. Cold air masses alter rainfall. Rivers shift their courses. Vegetation advances and retreats with astonishing speed on geological timescales. Entire ecosystems transform within a few thousand years, a brief interval compared with the length of human evolution. One lesser-known feature of this period is the remarkable abundance of the mammoth steppe. Stretching across enormous portions of Eurasia during colder intervals, this ecosystem is unlike any found today. Dry grasslands support extraordinary concentrations of large herbivores, including mammoths, horses, bison, reindeer, and saiga antelope. Predators such as wolves, cave lions, and hyenas follow these immense herds. Human hunters become part of this dynamic environment, learning migration patterns that repeat with seasonal precision. Not every landscape proves equally welcoming. Mountain ranges present formidable obstacles. Crossing them requires knowledge of passes that remain open despite snow and ice. High elevations bring thinner air, colder temperatures, and shorter growing seasons. Yet archaeological discoveries reveal that humans repeatedly penetrate these difficult environments. What survives in the record suggests an astonishing willingness to explore terrain that many other species avoid. Rivers become lifelines throughout this expansion. They provide fresh water, attract animals, support edible plants, and offer relatively predictable routes across unfamiliar territory. Valleys often contain richer soils, greater biodiversity, and more reliable shelter than surrounding uplands. Many later civilizations will eventually arise along major rivers, but their importance begins long before agriculture. For hunter-gatherers, rivers are natural highways connecting otherwise isolated landscapes. The psychological dimension of migration remains almost impossible to reconstruct, yet it deserves consideration. Every generation grows up with stories about places beyond the horizon. Children accompany adults on seasonal movements, gradually extending the limits of the known world. Curiosity likely exists alongside caution. Fear accompanies opportunity. Each successful journey expands collective knowledge, making future exploration slightly less uncertain. Modern archaeology occasionally uncovers moments that seem astonishingly intimate despite the immense passage of time. Ancient footprints preserved in soft sediment reveal adults walking beside children. Hearths contain traces of repeated occupation over many seasons. Animal bones bear cut marks left by stone tools, whose makers disappeared tens of thousands of years ago. These discoveries remind us that the migration is not an abstract movement of populations. It consists of individual lives filled with ordinary routines, preparing food, repairing tools, comforting children, and searching for tomorrow's meal. No single explanation fully accounts for the extraordinary pace with which Homo sapiens adapts to these diverse environments. Intelligence plays a role, but so do cooperation, flexible diets, cumulative learning, and the remarkable capacity to transmit knowledge across generations. Every successful adaptation becomes part of an expanding cultural inheritance that allows descendants to venture farther still. Yet as these migrants continue spreading across Southwest Asia and deeper into Eurasia, another reality slowly emerges from the shadows. They are not exploring an empty continent waiting to be occupied. Across forests, river valleys, and cold northern plains live other human populations who've already mastered these environments over hundreds of thousands of years. The paths of different branches of humanity are now drawing steadily closer, setting the stage for encounters that will permanently alter the genetic and cultural history of our species. Long before written history records the rise of kingdoms or the construction of monuments, the Earth is home to more than one kind of human. Modern people often imagine prehistory as a lonely stage occupied only by Homo sapiens, slowly spreading across an empty world. The evidence tells a far richer story. As the first successful migrations move deeper into Eurasia, they enter landscapes that have already been inhabited for hundreds of thousands of years by distant human relatives whose lives unfold according to their own remarkable histories. The most familiar of these relatives are the Neanderthals. Far from the crude caricatures once presented in popular culture, they are highly capable humans adapted to the demanding climates of Ice Age Europe and Western Asia. Their bodies are shorter and more powerfully built than those of most early Homo sapiens. Broad chests, strong limbs, and distinctive facial features help them endure cold environments where survival depends upon conserving heat and maintaining extraordinary physical endurance. For nearly 400,000 years, Neanderthals refined their way of life across an immense territory, stretching from the Atlantic coast to parts of Central Asia. They master stoneworking techniques of remarkable sophistication. They hunt dangerous, large animals at close range. Archaeological evidence suggests that they care for injured companions, with some individuals surviving severe disabilities that would have been impossible without long-term support from others. This alone reveals societies capable of compassion, planning, and cooperation. Some cave sites preserve hints of symbolic behavior as well. Pigments appear to have been collected deliberately. Eagle talons may have been worn as ornaments. Certain caves contain markings whose precise meanings remain uncertain. Scholars continue debating the extent and complexity of Neanderthal symbolic culture, but the outdated image of an unintelligent brute has steadily disappeared. Instead, they emerge as another successful human lineage, one that thrives for hundreds of millennia before modern humans ever arrive in significant numbers. Farther east, another mysterious population occupies parts of Asia. For decades, no one even realizes they exist. Their story begins not with a complete skeleton, but with a tiny finger bone discovered inside Denisova Cave in southern Siberia. At first glance, the fragment appears insignificant. Ancient DNA extracted from it, however, transforms the study of human evolution almost overnight. The genetic sequence belongs neither to Homo sapiens nor to Neanderthals. Instead, it represents an entirely different branch of humanity now known as the Denisovans. Remarkably little skeletal material has been found since then, only a handful of bones and teeth, but genetics reveals an unexpectedly broad influence. Modern populations across parts of Asia and Oceania still carry Denisovan DNA, proving that these mysterious humans once occupied a far larger range than the fossil record alone suggests. The Denisovans remain one of archaeology's greatest puzzles. Their physical appearance is still only partially understood because the available fossils are so limited. The evidence remains incomplete, yet their genetic legacy demonstrates that they are neither isolated curiosities nor evolutionary failures. They become part of the ancestry of millions of living people. There may even be additional human populations whose stories have not yet been fully uncovered. Genetic studies occasionally identify traces that cannot be easily explained by known groups. Some researchers propose the existence of so-called ghost populations, ancient human lineages that leave genetic contributions but almost no recognizable fossil evidence. These possibilities remain under investigation, reminding us that the human family tree is almost certainly more complicated than current discoveries can fully reveal. Against this remarkable backdrop, Homo sapiens continues expanding into Eurasia. The encounters that follow are neither simple wars nor peaceful coexistence across every region. Instead, they vary enormously according to place, time, climate, and circumstance. Sometimes different human groups may occupy neighboring territories for thousands of years. At other times, they likely compete for the same hunting grounds, water sources, or seasonal migration routes. Direct evidence of these interactions is frustratingly scarce. Bones bearing obvious signs of conflict are rare. Campsites often disappear beneath later sediments. Organic materials decay. Yet genetics preserves a record that neither weather nor erosion can completely erase. One of the greatest scientific discoveries of the 21st century reveals that almost every person living outside Africa today carries a small percentage of Neanderthal DNA. This finding overturns decades of assumptions that modern humans simply replace other populations without significant contact. Instead, interbreeding occurs repeatedly after Homo sapiens enters Eurasia. The descendants of those encounters survive into the present. The proportions vary among populations, but the conclusion is clear. Neanderthals do not vanish without leaving descendants. Part of their biological inheritance becomes woven permanently into the human genome. Likewise, Denisovan DNA survives most strongly among indigenous populations of Melanesia, Australia, Papua New Guinea, and parts of Southeast Asia, while smaller traces appear elsewhere across Asia. These inherited genes are far from meaningless curiosities. Some contribute to immune responses that help humans confront unfamiliar diseases encountered outside Africa. Others influence skin biology, metabolism, or adaptation to challenging environments. One remarkable Denisovan-derived genetic variant plays an important role in helping Tibetan populations thrive at extremely high elevations by improving the body's response to reduced oxygen. In this way, ancient encounters continue influencing human biology tens of thousands of years later. This discovery transforms how scientists understand human evolution. Earlier models often imagined separate human species replacing one another in neat succession. The reality resembles a braided river rather than a straight line. Different populations separate, evolve independently, meet again, exchange genes, and separate once more. Human evolution becomes a history of repeated divergence and reunion rather than simple replacement. That does not mean coexistence is always peaceful. Resources remain limited. Climate repeatedly disrupts ecosystems. Expanding populations inevitably create pressure on territories that have supported Neanderthal communities for countless generations. Scholars still debate the relative importance of competition, disease, demographic change, and climate fluctuations in the eventual disappearance of Neanderthals around 40,000 years ago. No single explanation fully accounts for their extinction. Modern humans may possess slightly larger social networks, allowing innovations to spread more rapidly. Greater population density may provide resilience after local disasters. More flexible diets could reduce vulnerability during periods when preferred prey becomes scarce. Climate instability almost certainly adds additional stress. Yet none of these factors alone appears sufficient. The end of the Neanderthals is likely the result of several forces acting together over thousands of years rather than one dramatic event. Perhaps the most profound realization is that the disappearance of these ancient relatives is not complete in the way once imagined. Their physical populations vanish, but fragments of their genetic heritage continue traveling through time inside billions of living cells. Every heartbeat, every immune response shaped by inherited genes, every adaptation carried across generations preserves a faint biological echo of meetings that occurred deep within the Ice Age. As Homo sapiens continues moving eastward and northward, these encounters become part of an expanding human story that is increasingly complex. Migration is no longer merely about crossing landscapes. It is about absorbing knowledge, exchanging genes, adapting to unfamiliar worlds, and gradually becoming a species unlike any that had existed before. The journey is still far from over, and the greatest environmental challenges have yet to appear. By the time modern humans establish themselves across much of Western Asia and begin pushing farther into Europe and the heart of the Eurasian continent, the migration has already become more than a movement across geography. It has become an experiment in survival played out against one of the harshest climates the human species has ever faced. Every valley entered, every mountain crossed, and every winter endured forces people to rethink the knowledge inherited from earlier generations. Success no longer depends simply on following familiar game. It depends on adapting faster than the world itself changes. The Ice Age is often imagined as a planet entirely buried beneath glaciers, but the reality is far more varied. Vast sheets of ice indeed dominate northern Europe, Greenland, and much of North America, reaching thicknesses measured in kilometers. Yet beyond these frozen expanses lies an enormous diversity of environments. Windswept grasslands stretch across central Eurasia. Boreal forests expand and retreat with changing temperatures. Dry steppes support immense herds of grazing animals. Rocky coastlines provide rich marine resources. Deserts appear and disappear as rainfall shifts over centuries. For human communities, this constantly changing mosaic presents endless challenges. A hunting route that proves reliable for several generations may suddenly become useless after vegetation changes. Rivers freeze earlier than expected. Lakes shrink or overflow. Animal migrations shift hundreds of kilometers. Families that fail to recognize these changes quickly may disappear without leaving any trace in the archaeological record. One of humanity's greatest advantages during this period is not superior strength, but extraordinary behavioral flexibility. Unlike highly specialized predators, Homo sapiens rarely depends upon a single source of food. When mammoths become scarce, hunters pursue reindeer or horses. Along rivers they catch fish. Coastal communities gather shellfish, seabirds, and seals. forests provide nuts, berries, mushrooms, and edible roots during favourable seasons. This remarkably broad diet reduces the risk posed by sudden environmental change. Fire becomes even more central to survival as populations move into colder regions. Archaeological evidence from numerous sites reveals carefully maintained hearths that serve as the centre of daily life. Fire-warm shelters dries damp clothing, preserves meat through smoking, and extends productive hours after sunset. It also provides psychological comfort in landscapes where darkness lasts long through winter months, and dangerous predators roam beyond the glow of the flames. Shelters themselves become increasingly sophisticated. Temporary windbreaks made from branches remain useful during seasonal travel, but longer occupations encourage more durable construction. In parts of Eastern Europe, archaeologists uncover circular structures built using mammoth bones combined with wood hides and earth. These remarkable dwellings demonstrate not only engineering skill but careful planning. Building them requires coordinated labour, abundant resources, and knowledge accumulated across generations. Clothing, though rarely preserved, likely represents another revolutionary adaptation. Bone needles discovered at several Upper Paleolithic sites suggest that people sew fitted garments rather than merely draping animal skins over their bodies. Well-tailored clothing traps heat more effectively, allowing extended activity in freezing conditions. Footwear becomes especially important, protecting against frostbite, while enabling travel across snow, ice, and rocky terrain. The human body itself begins responding to new environments in subtle ways. These biological changes do not occur overnight, nor do they transform every population equally. Instead, natural selection gradually favours traits that improve survival under specific local conditions. Skin pigmentation varies as populations settle in regions receiving different levels of ultraviolet radiation. Metabolism, immune function, and even aspects of body shape may slowly shift over thousands of generations. Scholars remain careful when interpreting these adaptations because the relationship between genetics, environment, and culture is extraordinarily complex. Clothing, shelter, diet, and social cooperation often reduce the selective pressures that might otherwise drive rapid biological change. Human evolution during this period is therefore shaped by the constant interaction between culture and biology, rather than by either force acting alone. One particularly fascinating challenge involves time itself. Survival in high-latitude environments requires understanding seasonal rhythms, unlike those experienced closer to the equator. Daylight changes dramatically through the year. Winters bring long periods of darkness, while summers offer extended hours of light. Animal migrations follow these cycles with remarkable consistency. Communities that learn to anticipate these patterns gain a decisive advantage. Evidence also suggests increasing sophistication in planning for the future. Large animals such as mammoths or bison provide enormous quantities of meat that cannot be consumed immediately by small groups. Drying, freezing, or smoking food extends its usefulness, allowing communities to survive periods when hunting proves unsuccessful. Such strategies require foresight, cooperation, and careful organization rather than simple reaction to immediate needs. The relationship between humans and predators also becomes more complicated. Ice Age Eurasia is home to cave lions, wolves, hyenas, leopards, bears, and other formidable carnivores. Rather than existing at the top of the food chain without challenge, humans occupy a shared landscape where caution remains essential. Caves that offer excellent shelter may already belong to bears. Fresh carcasses attract multiple predators simultaneously. Competition extends beyond hunting to the occupation of valuable habitats. Remarkably, archaeological discoveries occasionally reveal evidence of shared use of certain landscapes by humans and large carnivores over thousands of years. One season a cave serves as a bear's den. Centuries later, humans occupy it temporarily before moving on. Hyenas may later return. These repeated cycles remind us that prehistoric environments are dynamic systems rather than static settings waiting for human arrival. Another often overlooked aspect of migration is the role of children. Archaeological sites preserve footprints of young individuals alongside those of adults, suggesting that entire families travel together, rather than only specialized hunting parties. Children learn survival not through formal instruction, but by participating directly in daily life. They observe tool-making, gather edible plants, help maintain fires, and gradually memorize the landscapes their communities depend upon. In this way, cultural knowledge passes continuously from one generation to the next. This transfer of knowledge becomes one of humanity's most powerful evolutionary advantages. Unlike instinct alone, learned behavior can change rapidly. A successful hunting technique invented in one valley may spread across neighboring groups within a few generations. Better methods of preparing hides, constructing shelters, or preserving food become part of a growing cultural inheritance that accumulates far faster than biological evolution can operate. Even so, success is never guaranteed. The archaeological record contains numerous examples of local populations disappearing after environmental shifts. Some valleys once occupied for centuries are abandoned. Certain technologies appear briefly before vanishing. The evidence remains incomplete, but these patterns suggest that migration is marked not only by triumphs, but also by setbacks, failures, and repeated attempts to adapt. Yet with every challenge overcome, Homo sapiens becomes more capable of entering landscapes once considered beyond reach. The knowledge gained in frozen steppes, mountain passes, river valleys, and coastal environments prepares future generations for journeys that extend even farther across Eurasia. Soon, these expanding populations will begin following great waterways and shorelines that lead toward entirely new continents, carrying with them a growing mastery of survival that no previous human lineage has achieved on such a global scale. The farther humanity spreads across Eurasia, the more the landscape begins to resemble an intricate network of invisible pathways rather than an endless wilderness. Mountains funnel movement into narrow passes. Rivers carve natural highways through otherwise difficult terrain. Coastlines provide dependable food and clear directions for travel. These features do not compel migration, but they quietly shape its rhythm, guiding countless generations along routes that later disappear beneath forests, deserts, cities, or rising seas. What seems today like an accidental distribution of ancient archaeological sites increasingly reveals a pattern created by geography itself. Among the most important of these pathways are rivers. Long before anyone constructs roads or maps, waterways become reliable companions for travelling communities. Fresh water is essential, but rivers offer far more than drinking supplies. They attract grazing animals whose seasonal movements are easier to predict than those of wildlife scattered across open plains. Fish become a dependable source of protein, especially during periods when hunting larger game proves uncertain. Riverbanks also support edible plants, birds, and small mammals, creating rich ecosystems capable of sustaining repeated human occupation. Many archaeological sites from the late Pleistocene cluster along ancient river systems. This concentration is hardly surprising. Valleys often provide shelter from harsh winds, easier movement through difficult terrain, and diverse food resources within relatively short distances. Families returning season after season gradually accumulate intimate knowledge of these landscapes. They learn where floods occur, when fish spawn, which plants mature first in spring, and where herds are most likely to cross shallow channels. As migration continues eastward, some of the world's great rivers begin shaping humanity's future, long before agriculture transforms them into the cradles of civilization. Ancestors of later populations travel beside the Euphrates, the Tigris, the Indus, the Yellow River, and countless smaller waterways whose names are now forgotten. These rivers are not yet bordered by farms or cities. Instead, they flow through immense natural ecosystems where human presence remains scattered and mobile. Not every successful migration follows inland waterways. Increasing attention has turned toward the possibility that coastlines serve as equally important corridors. The so-called coastal migration hypothesis suggests that early Homo sapiens exploit marine environments while gradually expanding along the shores of the Indian Ocean and beyond. Rich supplies of shellfish, fish, seaweed, seabirds, and marine mammals may provide relatively stable food sources even when inland hunting becomes unpredictable. Support for this idea comes from several lines of evidence. Archaeological sites in South Africa demonstrate that humans exploit coastal resources surprisingly early. Shell middens fish remains, and specialized tools indicate a sophisticated understanding of marine environments. Similar discoveries appear at scattered locations farther east, although the record becomes increasingly difficult to interpret because so much of the ancient coastline now lies underwater. Sea levels during much of the Ice Age remain dramatically lower than they are today. Vast coastal plains stretch outward for many kilometers beyond modern beaches. Rivers empty into seas far from their present mouths. Islands are connected to mainland regions by exposed land bridges. Communities living near these ancient shores occupy landscapes that will eventually disappear beneath rising oceans as the climate warms after the last glacial maximum. This loss presents one of the greatest obstacles to understanding humanity's migration. Imagine attempting to reconstruct the history of a modern coastal nation after removing nearly every city, harbour, village and road built near the sea. Much of the evidence would vanish. Something similar has happened to prehistoric archaeology. Entire chapters of human expansion may now rest beneath layers of marine sediment inaccessible except through specialized underwater investigations. Despite these missing pieces, discoveries continue to reshape scientific understanding. Along submerged coastlines and ancient lake beds, researchers occasionally uncover stone tools, preserved footprints, or traces of campsites that survived extraordinary circumstances. Each new find reminds scholars that the visible archaeological record represents only a fraction of the landscapes our ancestors once occupied. Movement along coastlines also requires new skills. Unlike inland travel, marine environments demand careful observation of tides, currents, weather, and seasonal changes. Early watercraft almost certainly play some role in crossing rivers and narrow stretches of open water, although direct evidence rarely survives because wood decays rapidly. Nevertheless, the successful settlement of Australia, by at least 65,000 years ago, strongly suggests that early humans possessed the ability to cross significant bodies of water. Even at the lowest sea levels, reaching the Australian continent requires deliberate sea crossings. This achievement deserves particular attention because it represents one of the earliest known examples of humans intentionally entering a landmass completely separated by water. The journey may involve multiple short crossings rather than one long voyage, yet it still requires planning, cooperation, and confidence in technologies that leave almost no archaeological trace. No single explanation fully accounts for how these voyages are organized, but what survives in the record suggests remarkable ingenuity. As groups spread across increasingly diverse environments, navigation itself becomes an essential survival skill. There are no written maps, no compasses, and no permanent markers. Instead, knowledge exists within memory. Mountain silhouettes, distinctive rock formations, the direction of prevailing winds, seasonal stars, and the sound of distant rivers all contribute to a mental map passed from one generation to the next. Experienced travelers become living libraries, whose understanding of the landscape can determine whether an expedition succeeds or fails. This accumulated geographical knowledge also strengthens connections between neighbouring communities. Rather than existing as isolated bands wandering randomly across vast continents, many groups likely maintain overlapping territories, linked by seasonal gatherings, exchanges of marriage partners, and the sharing of valuable resources. Archaeological evidence reveals exotic stone materials transported hundreds of kilometers from their original sources, implying long-distance social networks far older than once imagined. These exchanges carry more than physical objects. New hunting methods spread alongside improved tool designs. Knowledge of distant water sources, dangerous predators, edible plants, and changing climates moves through human relationships. In many ways, information becomes the most valuable resource of all. A community that learns of favorable conditions beyond the horizon may avoid starvation simply because another group shares its experience. Scholars still debate the precise balance between inland and coastal migration routes. It is entirely possible that different populations follow different strategies depending upon local conditions. Some communities thrive beside rivers winding through continental interiors. Others exploit rich marine ecosystems along expanding shorelines. These approaches need not compete with one another. Together they illustrate the extraordinary flexibility that allows Homo sapiens to occupy environments stretching from tropical coasts to frozen northern plains. By now, the migration has reached a scale unlike anything previously witnessed in human history. Populations are spreading across Western Asia, Southern Asia, Europe, and into regions that had never before been inhabited by modern humans. Yet even greater distances remain ahead. Beyond the northeastern edge of Asia lies a landscape that exists only during the Ice Age, a vast land bridge joining two continents. Hidden beneath future oceans, this frozen world will eventually provide one of the most remarkable opportunities in the entire human journey, opening the path toward the last great inhabited continents on Earth. By the time humanity reaches the eastern reaches of Asia, the migration has already unfolded across tens of thousands of years. Entire cultures have appeared, adapted, and disappeared without leaving written memories behind. Children have grown into grandparents in landscapes that their distant ancestors could never have imagined. What began as gradual movement beyond Africa has become an extraordinary expansion across nearly half the planet. Yet the pace of this transformation is still accelerating, driven by a combination of changing climates, expanding knowledge, and an unmatched capacity to thrive in environments that differ dramatically from one another. Asia during the late Pleistocene is a continent of astonishing diversity. Dense temperate forests cover some regions while vast grasslands dominate others. High mountain chains divide river systems that flow toward different oceans. Tropical jungles flourish in the south, while frozen tundra stretches across the far north. Few other continents contain such striking environmental contrasts, and each demands unique survival strategies. Rather than following a single continuous migration route, Homo sapiens expands through multiple corridors simultaneously. Some communities remain close to coastlines rich in marine resources. Others establish themselves deep within river valleys. Still others move through open steppes where immense herds of grazing animals provide reliable food. These different pathways occasionally reconnect as neighbouring populations exchange tools, ideas, and marriage partners, creating a complex web of human relationships extending across remarkable distances. One of the most impressive achievements of this period is humanity's arrival in Sahul, the prehistoric supercontinent that combines present-day Australia, New Guinea, and Tasmania during times of lower sea level. Although these landmasses are connected to one another, they remain separated from mainland Asia by deep channels that never completely disappear. even during the lowest Ice Age sea levels. This means the first settlers must intentionally cross open water. Exactly how these journeys are organised remains one of archaeology's enduring mysteries. No wooden boats from 65,000 years ago have survived. Organic materials decay rapidly in tropical climates, leaving almost no direct evidence of the vessels themselves. Nevertheless, the archaeological record leaves little doubt that people successfully complete these crossings. Whether they use simple rafts, dugout canoes, or more sophisticated craft remains uncertain, but no single explanation fully accounts for the logistical planning required without acknowledging considerable technological skill. These voyages are unlikely to be accidents. Drifting across open water by chance cannot reasonably explain the establishment of lasting human populations across an entirely separate continent. Instead, deliberate exploration, careful preparation and cooperation almost certainly play central roles. Groups must gather food, transport children, maintain fresh water supplies, and navigate changing currents and weather conditions. Such undertakings suggest levels of planning that challenge outdated assumptions about early human societies. Upon reaching Sahul, migrants encounter ecosystems unlike any they have previously experienced. Giant marsupials roam the landscape alongside enormous flightless birds and massive reptiles. Some of these species have evolved in isolation for millions of years, adapting to predators and competitors very different from those found elsewhere. Humans become a completely new ecological force within this ancient world. The timing of many megafaunal extinctions across Australia has generated decades of scientific debate. Some researchers argue that human hunting contributes significantly to the disappearance of large animals. Others emphasize climate variability that alters vegetation and water availability. Increasingly, scholars favor combinations of these factors rather than a single simple cause. The evidence remains incomplete, but what survives suggests that even relatively small human populations can profoundly influence ecosystems already under environmental stress. Farther north and west, expansion into Europe continues along a different trajectory. Here, Homo sapiens enters regions long occupied by Neanderthals. Archaeological sites reveal increasingly sophisticated technologies associated with modern humans, including finely crafted blades, bone tools, ornaments, and eventually cave art of breathtaking complexity. Yet these developments do not appear everywhere simultaneously. Different regions adopt innovations at different times, reflecting the diversity of human experiences across the continent. One remarkable aspect of this expansion is the growing expression of symbolic behavior. Beads carved from shells, animal teeth, and ivory begin appearing at archaeological sites. Pigments such as red ochre are transported considerable distances. Carefully shaped ornaments suggest identities that extend beyond immediate survival. Although scholars continue debating the precise meanings of these objects, they almost certainly communicate social information, perhaps indicating family connections, group membership achievements, or shared traditions. The famous cave paintings of Western Europe emerged somewhat later within this expanding cultural landscape. Animals rendered with extraordinary skill cover cave walls deep underground, accompanied by abstract signs, hand stencils, and mysterious symbols whose meanings remain uncertain. These artworks reveal minds capable not only of practical adaptation, but also of imagination, memory, and symbolic thought expressed on a remarkable scale. Meanwhile, Eastern Asia develops along equally fascinating yet distinct pathways. Populations adapt to monsoon climates, mountainous terrain, and broad river basins that differ greatly from Western Eurasia. Stone tool traditions evolve in diverse ways, demonstrating that technological progress does not follow one universal pattern. Communities solve similar survival challenges using different combinations of local materials, inherited knowledge, and environmental opportunity. The archaeological record repeatedly reminds us that migration is never a simple story of constant forward movement. Some regions experience long periods of occupation before being abandoned. Others remain sparsely populated for thousands of years despite appearing suitable for settlement. Climate fluctuations repeatedly reshape opportunities. Volcanic eruptions, prolonged droughts, severe winters, and changing animal distributions all influence where people can successfully live. Perhaps one of the most underestimated achievements of these expanding populations is their ability to preserve cultural continuity across enormous distances and long periods of time. Oral traditions, practical knowledge, tool-making techniques, and survival skills pass through generations without writing. Every child becomes both student and future teacher. Every successful adaptation becomes part of an expanding cultural inheritance capable of outlasting individuals, families, and even entire communities. Genetic evidence increasingly supports this picture of interconnected yet diverse populations. Ancient DNA reveals repeated episodes of separation and reunion as groups spread across Asia. Some communities remain relatively isolated for millennia. Others encounter neighboring populations, exchange genes, and continue moving onward. Human history during this period resembles an intricate network rather than a series of isolated migrations. As these populations continue occupying the easternmost reaches of Eurasia, they approach another landscape transformed by the Ice Age. Lower sea levels expose an immense stretch of land connecting Siberia to what is now Alaska. This region, known today as Beringia, is not merely a narrow bridge but a vast ecological world in its own right, rich with grasslands, rivers, and wildlife. For thousands of years it stands ready to become the final great gateway of humanity's prehistoric expansion, opening a route toward continents that have never before known the presence of modern humans. At the northeastern edge of Asia, where modern maps show only a narrow stretch of water separating Russia from Alaska, the world of the Ice Age looks profoundly different. Sea levels are more than 100 meters lower than today, exposing a vast landscape that no longer exists. Instead of waves breaking against opposing coastlines, an immense plain stretches across the horizon. This lost country, known as Beringia, is not a simple land bridge but an entire ecosystem, thousands of kilometers wide, rich in grasslands, rivers, lakes, and wildlife. For thousands of years it becomes one of the most important crossroads in the history of humanity. To imagine Beringia merely as a passage between continents is to overlook its true significance. It is a homeland in its own right. Archaeological, geological, and genetic evidence increasingly suggest that human communities do not simply hurry across it. Many remain there for generations, perhaps even for thousands of years, adapting to its unique environment before eventually moving farther east into the Americas. This prolonged occupation has become known as the Beringian standstill hypothesis, one of several major models explaining how the ancestors of indigenous peoples of the Americas become separated from Asian populations before expanding into a new hemisphere. Scholars continue debating the exact timing of these events. Genetic analyses indicate that the ancestors of Native American populations diverge from related groups in Northeast Asia well before the widespread settlement of the Americas. The evidence remains incomplete, but many researchers conclude that a period of relative isolation in or near Beringia best explains this distinctive genetic signature. The details are still being refined as new discoveries emerge from archaeology and ancient DNA. Life in Beringia is demanding yet far from barren. Contrary to older assumptions, much of the region supports productive steppe tundra vegetation, capable of sustaining enormous herds of mammoths, bison horses, musk oxen and reindeer. These animals in turn support predators including wolves, cave lions and eventually human hunters. The climate is cold, but in many areas it's relatively dry, allowing grasses and flowering plants to flourish during the brief but intense summers. Survival in this environment requires exceptional planning. Food must be secured during seasons of abundance and preserved for long winters. Clothing fashioned from carefully prepared hides becomes indispensable. Shelters are constructed to withstand freezing winds sweeping across open plains. Families likely maintain intimate knowledge of seasonal animal migrations, frozen river crossings, and sheltered valleys, where resources remain dependable year after year. One remarkable aspect of Beringian life is its isolation. During colder periods, enormous ice sheets block movement into much of North America from the east and south. To the west lies Asia. Communities occupying Beringia may find themselves living in a world that is geographically connected yet effectively separated by environmental barriers. This isolation likely shapes both their genetics and their cultural traditions over many generations. Eventually, changing climates begin opening new possibilities. As glaciers slowly retreat near the end of the last ice age, routes into the Americas become increasingly accessible. Exactly which pathways are used, first, remains one of archaeology's most active areas of research. For much of the 20th century, the dominant explanation centers on an interior ice-free corridor, opening between the massive Laurentide and Cordilleran ice sheets. According to this model, migrating populations travel south through this corridor before spreading rapidly across North and South America. More recent discoveries have complicated this picture. Archaeological sites predating the full opening of the interior corridor suggest that at least some populations may instead follow the Pacific coastline. This coastal migration hypothesis proposes that people travel along shorelines exploiting marine resources while moving southward by boat or along exposed coastal plains. Unfortunately, much of this ancient coastline now lies beneath the Pacific Ocean, due to post-glacial sea level rise making direct evidence difficult to recover. No single explanation fully accounts for every archaeological discovery. Increasingly, many scholars suggest that both routes may play important roles at different times. Some communities likely move inland once suitable corridors become available, while others exploit coastal environments. Human migration, as elsewhere in prehistory, is probably more flexible and varied than any single model can fully capture. One of the strongest pieces of evidence for an early human presence in the Americas comes from sites such as Monte Verde in southern Chile. Dating to at least 14,500 years ago, and possibly earlier depending on ongoing research, this settlement demonstrates that people reached the southern part of South America surprisingly quickly after entering the continent. Such rapid expansion suggests remarkable mobility, combined with efficient adaptation to diverse environments. Within only a few thousand years, humans occupied deserts, rainforests, high mountain plateaus, coastal regions, and Arctic environments, stretching from Alaska to Patagonia. Few migrations in natural history match this extraordinary geographic range. Communities encounter giant ground sloths, mastodons, glyptodonts, saber-toothed cats, and numerous other species that have evolved in relative isolation from human hunters. As in Australia, the disappearance of many large American mammals near the end of the Ice Age has generated extensive scientific debate. Some researchers emphasize the impact of increasingly skilled human hunters. Others point to rapid climatic warming that transforms vegetation and water availability. A growing body of evidence indicates that these forces likely interact, placing unprecedented pressure on ecosystems already undergoing dramatic environmental change. Meanwhile, the human populations themselves begin diversifying. Isolated by mountains, forests, deserts, and immense distances, communities develop distinct cultural traditions suited to local environments. Hunting technologies evolve. Tool styles vary from region to region. Knowledge of edible plants expands. Fishing becomes central in some areas while others continue relying heavily on large game. These differences emerge not because people cease sharing common ancestry, but because adaptation continually reshapes ways of life. Ancient DNA continues revolutionizing this field. Genetic studies increasingly reveal complex patterns of migration, local isolation, and later movement within the Americas. Although many details remain uncertain, the overall picture confirms that the settlement of the New World is neither instantaneous nor uniform. It unfolds through repeated movements, environmental adaptation, and the gradual establishment of communities across landscapes, unlike any previously encountered. Perhaps the most profound lesson from Beringia is that one of the greatest migrations in history does not occur through dramatic conquest, but through patience measured in generations. Families raise children beneath skies dominated by northern lights. Hunters memorize seasonal routes across frozen plains. Elders preserve knowledge that allows their descendants to survive worlds constantly reshaped by ice and climate. Step by step, century after century, these communities carry humanity into the last great continents awaiting permanent settlement, with people now established across Africa, Europe, Asia, Australia, and the Americas. The ancient migration has transformed Homo sapiens from one regional population into a truly global species. Yet geography alone is not the greatest legacy of this journey. As populations spread farther apart, they also carry with them ideas, technologies, beliefs, and social traditions that will slowly connect distant human worlds in ways that neither they nor their descendants could yet imagine. By the time human communities occupy nearly every major continent except Antarctica, the migration has become something greater than the movement of people alone. Every journey carries invisible cargo alongside stone tools, animal hides, and carefully tended fires. Knowledge travels with each generation. Skills learned in one landscape are modified in another. Symbols, beliefs, hunting strategies, and ways of understanding the natural world spread across astonishing distances, slowly weaving together the foundations of what will eventually become human civilization. Unlike genes, which change gradually over many generations, culture can transform with remarkable speed. A successful method of shaping stone into sharper blades may spread from one neighboring community to another within decades. Improved techniques for sewing clothing or preserving food may quickly become common across regions linked by seasonal gatherings and social exchange. This ability to accumulate knowledge without waiting for biological evolution gives Homo sapiens an extraordinary advantage over every other human lineage. The archaeological record increasingly reveals that prehistoric populations are far more interconnected than once believed. Certain types of high-quality stone appear hundreds of kilometers from their natural sources. Shells collected along distant coastlines are discovered deep within continental interiors. Rare pigments such as red ochre travel across vast landscapes, despite offering little direct survival value. These materials suggest networks of exchange extending well beyond the daily movements of individual hunting bands. Such exchanges likely involve much more than physical objects. Information itself becomes one of humanity's most valuable resources. News of changing animal migrations, newly discovered water sources, dangerous weather patterns, or unfamiliar landscapes can determine whether neighboring communities survive difficult years. Oral traditions preserve these experiences, allowing future generations to benefit from events they never personally witness. Language almost certainly plays a central role in this remarkable process. Although spoken words leave no fossils, the complexity of coordinated hunting, long-distance cooperation, and cultural transmission strongly suggests sophisticated communication. Stories become living archives. Elders pass along practical knowledge wrapped within memorable narratives. Seasonal cycles, dangerous locations, medicinal plants, and social customs all become easier to remember when embedded within shared traditions. Scholars continue debating exactly when fully modern language develops, because direct evidence is impossible to recover. What survives in the archaeological record nevertheless points toward increasingly complex societies, capable of organizing activities that require careful planning and cooperation. Large hunting expeditions, long-distance exchanges, and eventually artistic expression all imply communication far beyond simple signals or immediate needs. Art itself begins appearing with increasing frequency as Homo sapiens expands across the globe. Some of the earliest known examples include engraved ochre pieces from southern Africa, dating back tens of thousands of years before the famous cave paintings of Europe. These abstract patterns suggest symbolic thinking whose precise meaning remains uncertain. They may represent ownership, identity, ritual, memory, or something entirely different. The evidence remains incomplete, but they reveal minds concerned with ideas extending beyond immediate survival. As human populations spread, artistic traditions diversify rather than remaining uniform. In Europe, magnificent cave paintings depict horses, bison, mammoths, lions, rhinoceroses, and other animals with extraordinary skill. In Australia, rock art traditions continue evolving over tens of thousands of years, creating one of the world's longest continuous artistic records. Across Asia, engraved objects, carved figurines, and decorated tools reveal equally rich symbolic worlds adapted to local cultures and environments. One lesser-known aspect of these artistic traditions is their remarkable durability. Some rock art sites remain culturally significant for thousands of years, with later generations returning repeatedly to the same locations. This continuity suggests that certain landscapes acquire lasting social or spiritual importance, becoming places where memory itself is anchored within the environment. Burial practices also become increasingly diverse during this period. Archaeologists uncover graves containing carefully arranged bodies, accompanied by ornaments, tools, pigments, or animal remains. These discoveries suggest growing attention to death as a social event rather than simply the end of biological life. Exactly what these communities believe about death remains unknowable, yet their actions reveal emotional and symbolic complexity that resonates across immense stretches of time. One particularly moving discovery comes from individuals who survive serious injuries or illnesses that would have been impossible to endure without prolonged care from others. Skeletons showing healed fractures, severe disabilities, or advanced age demonstrate that prehistoric societies frequently invest time and resources in vulnerable members. Such evidence challenges simplistic portrayals of Ice Age life as nothing more than relentless competition. Cooperation remains one of humanity's defining strengths. Migration also encourages remarkable flexibility in social organization. Small family groups remain essential, but wider alliances likely become increasingly important as populations spread across unfamiliar territory. Marriage between neighboring communities strengthens social bonds while reducing the risks associated with prolonged isolation. Genetic evidence supports repeated contact between populations that are geographically separated, yet still connected through occasional exchanges over long periods. This growing web of relationships gradually creates something unprecedented. Humanity begins functioning not as isolated pockets of survival, but as an expanding network of knowledge. Innovations developed in one region may eventually influence distant populations through countless intermediate exchanges. Progress becomes cumulative rather than isolated. Environmental adaptation continues shaping cultural diversity. Arctic communities develop specialized hunting methods for marine mammals and cold weather survival. Tropical populations master dense forests rich in edible plants, but difficult to navigate. Highland groups adapt to thinner air and rugged terrain. Desert inhabitants learn to exploit scarce water sources with astonishing efficiency. Every environment encourages unique solutions while preserving a shared human capacity for learning. Interestingly, genetic studies reveal that cultural exchange often extends farther than large-scale migration itself. Ideas can spread between neighboring populations even when relatively few people actually relocate. This distinction becomes increasingly important for understanding later prehistory, where technologies such as agriculture, metallurgy, and pottery frequently expand through combinations of migration and cultural diffusion, rather than through one process alone. The evidence remains incomplete because much of humanity's intellectual history leaves few physical traces. Countless songs, myths, teaching methods, and spoken histories vanish forever when the last individuals who remember them die. Yet fragments survive indirectly through artifact settlement patterns, symbolic objects, and increasingly through ancient DNA, allowing researchers to reconstruct pieces of this invisible cultural landscape. No single explanation fully accounts for humanity's extraordinary success. Superior intelligence alone cannot explain it. Neither can physical strength, climate, nor technology in isolation. Instead, the defining characteristic appears to be the ability to combine cooperation, communication, memory, innovation, and adaptation into an ever-expanding system of shared knowledge. Migration provides the framework, but culture becomes the force that transforms scattered populations into the ancestors of every civilization yet to come. Even as these cultural networks strengthen, the planet itself is preparing for another profound transformation. The great ice age that has shaped human history for tens of thousands of years is slowly drawing to a close. Glaciers begin retreating, seas start rising, rivers change course. Entire landscapes that guided generations of migrants will soon disappear beneath expanding oceans, forcing humanity to adapt once again to a rapidly changing world. For tens of thousands of years, the rhythm of human migration is shaped by a planet locked in the grip of the Ice Age. Glaciers advance and retreat, sea levels rise and fall, grasslands expand before giving way to forests, and rivers repeatedly carve new paths across the land. Entire generations grow up believing the world they inherit will remain familiar to their children. Yet beneath this apparent stability, enormous climatic forces are already gathering. Around the end of the last ice age, the Earth enters one of the most dramatic periods of environmental transformation that Homo sapiens has ever experienced, and once again survival depends upon the ability to adapt. The warming that begins roughly 20,000 years ago is neither perfectly smooth nor evenly distributed across the globe. Temperatures fluctuate over centuries and even millennia. Brief returns to colder conditions interrupt longer warming trends. One of the most striking examples is the Younger Dryas, a sudden cooling event beginning about 12,900 years ago. For more than 1,000 years, many regions of the Northern Hemisphere experience a sharp return to colder conditions before warming resumes once again. Scholars continue debating the precise mechanisms responsible for this abrupt climate reversal. The leading explanation points toward massive releases of meltwater from retreating ice sheets disrupting the circulation of the North Atlantic Ocean. Other hypotheses have been proposed over the years, including more speculative ideas involving cosmic impacts, but the evidence supporting those alternatives remains disputed. What survives in the geological record strongly suggests that changes in ocean circulation play a major role, although research continues to refine the details. For the people living through these changes, scientific explanations are impossible. They simply witness a world becoming unpredictable. Hunting grounds that sustained families for generations begin changing. Familiar plants disappear from certain regions while new species gradually arrive. Rivers shift their channels. Wetlands expand in one valley and vanish in another. Seasons become less reliable. The landscape itself appears to be transforming within the span of human memory. Perhaps nowhere is this transformation more dramatic than along the world's coastlines. As enormous ice sheets melt, trillions of tons of fresh water return to the oceans. Sea levels begin rising not over decades but over many centuries. Even so, the cumulative effect is astonishing. More than 100 meters of sea level rise eventually flood vast coastal plains that had served as migration routes, hunting grounds, and settlement areas for countless generations. Entire landscapes disappear beneath advancing waters. The exposed plains of Beringia slowly vanish, severing the land connection between Asia and North America. The enormous lowlands that once joined Britain to continental Europe, known today as Doggerland, gradually sink beneath the North Sea. Across Southeast Asia, the broad continent of Sunderland fragments into the islands of Indonesia and Malaysia familiar today. Communities living on these ancient plains are forced to retreat inland as the sea steadily claims more territory. The archaeological consequences of this flooding are profound. Many of humanity's earliest coastal settlements now lie submerged beneath oceans, estuaries, and continental shelves. Their disappearance helps explain why the prehistoric record often seems incomplete. Archaeologists are effectively attempting to reconstruct a story after some of its most important chapters have been washed away. Modern underwater archaeology is beginning to recover small portions of this lost world. Fishing vessels occasionally bring up stone tools from the seabed. Divers discover submerged forests where trees still stand rooted in ancient soils. Sonar surveys reveal drowned river channels winding beneath modern seas. Each discovery offers another glimpse into landscapes that shaped generations of human lives before vanishing beneath rising water. Climate change also reshapes vegetation on a continental scale. As temperatures rise, forests expand northward into areas previously dominated by open grasslands. The mammoth steppe, one of the richest Ice Age ecosystems, gradually declines. Large grazing animals that depend upon these expansive grasslands become increasingly restricted or disappear entirely. Mammoths survive longest on isolated Arctic islands, before finally becoming extinct, while other species retreat into shrinking habitats unable to support their former populations. Human communities face difficult decisions. Hunting strategies perfected over thousands of years become less effective as familiar prey grows scarce. Dense forests require different techniques than open plains. Smaller animals become more important. Fishing assumes a greater role in many regions. Gathering wild cereals, nuts, and edible plants expands as changing ecosystems provide new opportunities. The relationship between climate and human innovation becomes increasingly apparent during this period. Rather than merely responding passively to environmental change, communities experiment with new ways of living. Grinding stones become more common as people process seeds and grains. Storage pits allow food to be preserved across seasons. Semi-permanent settlements begin appearing in especially productive environments, where abundant resources reduce the need for constant movement. One fascinating example comes from the Natufian culture of the Levant. Living roughly 15,000 years ago, these hunter-gatherers establish relatively permanent villages while still relying largely on wild resources. Stone houses, cemeteries, and evidence of intensive harvesting suggest societies already moving toward lifestyles that differ significantly from the highly mobile bands of earlier millennia. Yet they remain hunter-gatherers, demonstrating that the transition to farming is gradual rather than sudden. Scholars still debate the precise relationship between climate change and the eventual emergence of agriculture. Some argue that environmental instability encourages experimentation with cultivating plants. Others emphasize growing population densities or increasingly complex social organization. No single explanation fully accounts for this monumental transformation. Instead, agriculture appears to emerge through a combination of ecological opportunity, cultural innovation, and local circumstances that vary across different regions. Meanwhile, migration itself does not simply end because suitable territories have been occupied. Instead, its character changes. Large-scale expansion into previously uninhabited continents becomes increasingly rare, but local movements continue everywhere. Communities relocate in response to rising seas, shifting rivers, volcanic eruptions, droughts, and changing ecosystems. Human history remains one of continual movement even after the great prehistoric migrations are largely complete. The Younger Dryas eventually comes to an end. Temperatures rise rapidly once more, ushering in the relatively stable Holocene epoch that continues today. Compared with the dramatic climate fluctuations of the Ice Age, the Holocene offers a remarkably predictable environment. Seasons become more consistent. Glaciers retreat farther north. Forests stabilize across much of Europe and Asia. Rivers settle into more familiar courses. This newfound stability creates conditions unlike any most previous human generations have experienced. Without realizing it, the descendants of the great migrants are entering an entirely new chapter of human history. The world that once demanded constant movement is beginning to reward permanence. Villages will soon become towns. Towns will eventually become cities. The ancient migration that carried humanity across the globe is preparing to give rise to something equally revolutionary. The first societies rooted not in endless travel, but in lasting settlement. As the glaciers retreat and the climate settles into the comparatively stable conditions of the Holocene, humanity finds itself living in a world unlike any its ancestors have known. For hundreds of thousands of years, movement has been the defining feature of survival. Families follow migrating herds. Camps are abandoned as seasons change. Rivers shift, forests advance, and coastlines slowly move inland. Adaptability has always meant mobility. Now, in several remarkable regions, a different possibility begins to emerge. Instead of following resources across the landscape, some communities discover that resources can increasingly be encouraged to remain where people choose to live. This transformation does not happen everywhere, nor does it happen all at once. There is no single inventor of agriculture and no universal moment when humanity suddenly abandons hunting and gathering. Across the globe, different populations experiment with local plants and animals according to the environments they inhabit. Some of these experiments fail, others gradually reshape the future of civilization. The Fertile Crescent, stretching across parts of the modern Middle East, provides one of the earliest and best-studied examples. Wild varieties of wheat, barley, lentils, peas, and other edible plants grow naturally across valleys and hillsides. For countless generations, hunter-gatherers harvest these resources without cultivating them. Gradually, perhaps almost imperceptibly, people begin influencing which plants thrive near their settlements. At first, the changes are subtle. Seeds from desirable plants are accidentally scattered near campsites. Areas around villages are cleared of competing vegetation. Certain grasses receive more attention because they produce larger grains or mature more predictably. Over many generations, natural selection and human preference begin working together. plants themselves slowly change, becoming increasingly dependent upon cultivation. Animals undergo similar processes. Wild sheep, goats, pigs, and cattle are initially hunted like any other prey. Eventually, some populations begin managing herds rather than simply pursuing them. Young animals may be captured instead of killed. Selective breeding gradually favors traits that make certain species easier to control. Domestication unfolds across centuries rather than within a single generation. Scholars still debate why these transitions occur when they do. Climate stability likely plays an important role by making seasonal harvests more predictable. Growing populations may place increasing pressure on wild food supplies. Social competition, ritual gatherings, and expanding trade networks could also encourage more reliable food production. The evidence remains incomplete, and no single explanation fully accounts for the diversity of agricultural origins around the world. The remarkable point is that these developments arise among the descendants of people whose ancestors have spent tens of thousands of years adapting through movement. The skills acquired during the Great Migrations, careful observation of plants, intimate understanding of animal behavior, detailed knowledge of seasonal cycles, and extraordinary patience become the very foundation upon which farming eventually develops. Agriculture is not a rejection of hunter-gatherer knowledge, it is built upon it. Permanent villages begin expanding in size. Stone houses replace temporary shelters in many regions. Storage buildings appear, protecting harvested grain from moisture and pests. Cemeteries grow larger as generations are buried in the same places. Communities develop increasingly strong attachments to particular landscapes, because their survival now depends upon fields, orchards, and managed herds, rather than constantly shifting hunting territories. With permanence comes entirely new social challenges. Mobile hunter-gatherer bands often possess relatively limited material wealth, because possessions must be carried during frequent movements. Permanent settlements allow food surpluses to accumulate. Houses vary in size. Storage capacity differs between families. Over time, differences in wealth, influence, and authority become more visible. This shift does not happen uniformly across every early farming society, but archaeology reveals growing evidence of social complexity. Larger settlements require coordination for building projects, water management, food storage, and defense. Specialized crafts emerge as some individuals devote increasing attention to pottery weaving, stone working, or ritual activities instead of producing all their own necessities. Trade expands dramatically. Communities exchange obsidian seashells, pigments, animal products, and eventually metals across astonishing distances. Many of these exchange routes follow pathways first established by migrating hunter-gatherers thousands of years earlier. Ancient movement continues shaping later civilization long after the great migrations themselves have slowed. One fascinating example of this continuity lies in the spread of obsidian, a volcanic glass prized for producing exceptionally sharp blades. Archaeologists can often identify the precise volcanic source of obsidian artifacts through chemical analysis. These studies reveal exchange networks extending hundreds of kilometers across prehistoric landscapes, demonstrating that early farming communities remain connected to distant neighbors through relationships inherited from much older traditions of mobility. The rise of permanent settlements also transforms humanity's relationship with time. Mobile societies often organize life around seasonal migrations and recurring natural events. Farming introduces additional cycles involving planting, harvesting, irrigation, storage, and livestock management. Calendars become increasingly valuable. Careful observation of the sun, moon, and stars acquires practical significance beyond navigation alone. Monumental architecture soon follows in several regions. Sites such as Göbekli Tepe challenge long-held assumptions by suggesting that large ceremonial structures may appear before fully established farming societies. Massive stone pillars arranged with remarkable precision demonstrate levels of organization once thought impossible among communities that have not yet developed agriculture in its mature form. Scholars continue debating the exact social context of these monuments, but they reveal that cooperation on an impressive scale precedes many later civilizations. Meanwhile, agriculture develops independently in other parts of the world. Rice cultivation gradually emerges in East Asia. Millet becomes important across northern China. Maize, beans, and squash are domesticated in the Americas thousands of years later. New Guinea develops its own agricultural traditions adapted to tropical highlands. Each region follows unique pathways shaped by local environments and available species. Despite these differences, all share one fundamental connection. None of these societies emerge in isolation from humanity's earlier migrations. Every farming community descends from people who once survived through movement across changing landscapes. Their ancestors carry knowledge accumulated during countless generations of exploration, adaptation, and environmental observation. Without those migrations, the later agricultural revolutions could never have unfolded in the forms we recognize today. Even as villages expand and fields spread across fertile valleys, echoes of the ancient journeys remain visible. Trade routes continue linking distant populations. Seasonal hunting persists alongside farming in many regions. Oral traditions preserve memories of ancestral movements, though often transformed into myths whose historical origins become increasingly difficult to recognize. Humanity appears settled at last, yet beneath the foundations of every emerging civilization lies the legacy of people who once walked across continents with little more than stone tools, shared knowledge, and an extraordinary determination to survive. As villages become larger and the first civilizations begin taking shape, the physical traces of humanity's ancient migration grow increasingly difficult to recognize. New houses are built upon older campsites. Fields replace hunting grounds. Rivers alter their courses, burying settlements beneath layers of silt. Forests reclaim abandoned clearings, while rising seas permanently conceal countless coastal landscapes. By the time written history finally appears in places such as Mesopotamia and Egypt, the greatest migration in human history has already ended tens of thousands of years earlier, leaving behind only scattered clues hidden beneath the earth. For generations, archaeologists attempting to reconstruct this distant past work with remarkably limited evidence. A broken stone blade discovered in one valley may be separated by hundreds of kilometers from the nearest human fossil. Animal bones bearing cut marks hint at hunting practices, but reveal little about language or social organization. Charcoal from an ancient hearth records the use of fire without preserving the stories shared around its flames. Reconstructing prehistoric migration often resembles assembling an enormous puzzle after most of its pieces have disappeared. Fortunately, modern science has transformed the search. Archaeology no longer relies solely on visible artifacts. Advances in geology, chemistry, genetics, remote sensing, and environmental reconstruction now allow researchers to recover information that would have seemed impossible only a few decades ago. Each discipline contributes a different perspective, and together, they are gradually revealing a far richer picture of humanity's prehistoric journey. One of the most powerful tools is radiocarbon dating. Developed during the 20th century, this technique measures the decay of radioactive carbon preserved within once living material. Charcoal from ancient fires, fragments of wood, bone, collagen, and plant remains can often be dated with remarkable precision. Radiocarbon dating does not answer every question, and it becomes less reliable beyond roughly 50,000 years. but it provides an essential chronological framework that allows archaeologists to place discoveries into meaningful historical sequences. Even more remarkable are recent advances in ancient DNA. For much of archaeological history, genetic information seemed permanently lost after death. Heat, moisture, bacteria, and time gradually destroy DNA molecules, leaving little hope of recovery. Yet improvements in laboratory techniques have allowed researchers to extract tiny surviving fragments from bones, teeth, and even cave sediments under favorable conditions. These discoveries have revolutionized the study of human migration. Ancient genomes reveal relationships invisible to traditional archaeology. Two communities using similar stone tools may prove only distantly related genetically. Conversely, populations separated by thousands of kilometers may share surprisingly recent ancestry. Genetic evidence has uncovered repeated episodes of migration isolation and interbreeding that no one could confidently reconstruct from artifacts alone. Perhaps the most dramatic example is the discovery of the Denisovans. Without ancient DNA, a small finger bone found inside Denisova Cave would likely have remained little more than an interesting fossil fragment. Genetic analysis instead reveals an entirely distinct branch of humanity, whose descendants still contribute DNA to millions of people alive today. One tiny bone reshapes our understanding of human evolution across an entire continent. The same techniques continue producing unexpected discoveries. Scientists have identified ancient migrations that leave almost no obvious archaeological signature. In some cases, populations appear to replace earlier inhabitants, with relatively little evidence of violent conflict. In others, neighboring groups exchange genes while maintaining distinct cultural traditions for centuries. Human history becomes increasingly complex with every newly sequenced genome. Stable isotope analysis offers another remarkable window into prehistoric lives. Tiny chemical differences preserved within bones and teeth reflect the foods individuals consume and even the water they drink during childhood. By comparing these isotopic signatures with local geological conditions, researchers can sometimes determine whether a person grows up in the same region where they are eventually buried or migrates across significant distances during life. This approach has revealed surprising levels of mobility in many prehistoric societies. Individuals buried together are not always lifelong neighbours. Some travel hundreds of kilometres before settling elsewhere. Others move between ecological zones as part of seasonal or long-term migrations. The ancient world proves far more dynamic than earlier generations of scholars often imagined. Environmental science has become equally important. Sediment cores extracted from lake beds preserve microscopic pollen grains deposited year after year. By identifying these pollen assemblages, scientists reconstruct changing vegetation over thousands of years. Layers of volcanic ash provide precise chronological markers linking distant archaeological sites. Ice cores recovered from Greenland and Antarctica preserve ancient atmospheric conditions, revealing abrupt climate changes that influence human movement across continents. Remote sensing technologies have opened still more possibilities. Satellite imagery reveals buried river channels hidden beneath modern deserts. Airborne laser scanning, known as LiDAR, penetrates dense forest canopies to expose ancient landscapes invisible from the ground. In tropical regions once considered archaeologically inaccessible, vast networks of settlements, roads, and agricultural systems are now emerging through digital mapping. Underwater archaeology is beginning to explore landscapes submerged since the end of the Ice Age. Divers investigate drowned forest beneath the North Sea. Robotic vehicles survey ancient shorelines buried beneath coastal sediments. Stone tools recovered from submerged plains hint at communities that live where fishing boats now sail above open water. The work is technically demanding and often expensive, but each discovery expands humanity's understanding of prehistoric migration. Despite these extraordinary advances, uncertainty remains a defining feature of prehistoric research. Scholars frequently revise earlier conclusions as new evidence emerges. Dates become more accurate. Migration routes are refined. Long-standing assumptions are challenged. This continual revision is not a weakness of science, but one of its greatest strengths. Every new discovery is tested against existing evidence, allowing increasingly reliable reconstructions of the past. One fascinating lesson from recent decades is how often apparently isolated discoveries eventually fit into broader patterns. A single footprint preserved beside an ancient lake may later align with genetic evidence, climatic reconstructions, and stone tool traditions from neighbouring regions. What first appears insignificant gradually becomes part of a much larger story spanning continents and millennia. No single method can fully reconstruct humanity's ancient migration. Archaeology provides artifacts, genetics reveals ancestry, geology explains changing landscapes, chemistry uncovers individual life histories, climate science reconstructs environmental pressures. Together they form a multidisciplinary picture far richer than any single field could achieve alone. Even so, countless questions remain unanswered. Entire populations may still await discovery beneath submerged coastlines or unexplored caves. Additional branches of the human family tree may yet emerge from ancient DNA. Unknown migration routes may lie hidden beneath deserts, forests, or modern cities. The evidence remains incomplete, reminding us that the greatest journey in human history is still being rediscovered piece by piece, one excavation and one scientific breakthrough at a time. As scientific discoveries illuminate more of humanity's distant past, another story unfolds alongside the evidence. It is a story not of fossils, ancient DNA, or buried campsites, but of myths, legends, and modern speculation. Few subjects inspire as much imagination as the origins of our own species. Across centuries, people have searched for dramatic explanations that promise hidden civilizations, forgotten continents, or secret ancestors waiting just beyond the edge of accepted history. Some of these stories contain echoes of real events, while others drift far beyond what the evidence can support. Long before archaeology became a scientific discipline, nearly every culture developed traditions explaining where its people came from. Some described ancestors emerging from caves or mountains. Others spoke of great migrations led by legendary figures, sacred animals, or divine beings. Still others remembered catastrophic floods that forced survivors to seek new lands. These narratives served important cultural and spiritual purposes, preserving identity values and collective memory, rather than providing literal historical records. Interestingly, certain myths may preserve distant reflections of genuine environmental change. Around the world, flood traditions appear in many societies. Because sea levels rise dramatically after the last ice age, some researchers have explored whether stories of advancing waters preserve cultural memories of disappearing coastlines passed through many generations. The possibility remains intriguing, but scholars urge caution. Similar stories can arise independently in different societies because floods are common natural disasters. No single explanation fully accounts for the remarkable distribution of flood narratives across human cultures. Another enduring legend centers on lost continents. Among the most famous is Atlantis, first described by the ancient Greek philosopher Plato. Over the centuries, Atlantis has been transformed from a philosophical tale into a supposed prehistoric super-civilization by countless books, documentaries, and popular theories. Some versions even claim that Atlantis becomes the true source of all later civilizations before vanishing beneath the sea. Mainstream archaeology does not support these claims. Despite decades of investigation, no credible evidence demonstrates the existence of a technologically advanced Ice Age civilization matching the popular image of Atlantis. This does not mean ancient coastal settlements never disappeared beneath rising seas. They certainly did. Entire landscapes, including Doggerland in the North Sea and large portions of Sunderland in Southeast Asia, were submerged as glaciers melted. However, these drowned worlds were inhabited by hunter-gatherer communities rather than the lost global empires often portrayed in speculative accounts. Doggerland provides an excellent example of how reality can be both less sensational and more fascinating than fiction. During the Ice Age, this vast plain connected Britain to continental Europe. Rivers crossed open grasslands where humans hunted animals and established camps over thousands of years. As sea levels gradually rose, much of this landscape disappeared beneath the North Sea. Fishing vessels occasionally recover mammoth bones, stone tools and fragments of prehistoric life from the seabed, confirming that an entire human world now lies underwater. Yet its story emerges from careful archaeology rather than mythical civilization. Another popular misconception concerns the speed of prehistoric migration. Dramatic illustrations often depict enormous caravans sweeping rapidly across continents. In reality, the movement is extraordinarily slow. Generations may spend centuries within relatively small territories before gradually expanding farther. A child born at the edge of a community's range may eventually settle only a few dozen kilometers beyond where their parents lived. Across thousands of years, these seemingly modest movements accumulate into global expansion. The misconception likely arises because modern maps compress immense spans of time into simple arrows. A single line stretching from Africa to Australia may represent tens of thousands of years, involving countless communities, changing climates, failed migrations, and repeated adaptations. The visual simplicity conceals the remarkable patience of the actual process. Another area frequently misunderstood involves genetic ancestry. Commercial DNA testing has sparked enormous public interest in human origins, but simplified interpretations sometimes create misleading impressions. Discovering that an individual carries a small percentage of Neanderthal ancestry does not mean they descend from a recent Neanderthal ancestor in the ordinary sense. Instead, those genetic contributions result from interbreeding events occurring roughly 50 to 60,000 years ago. Since then, countless generations of recombination have dispersed these ancient fragments throughout human populations. Likewise, genetics cannot neatly define cultural identity. People sharing similar ancestry may develop entirely different languages, traditions, and ways of life. Conversely, neighbouring societies with distinct genetic backgrounds often exchange ideas, technologies, and customs for centuries. Human history has always involved both biological movement and cultural interaction, and the two do not always follow identical paths. Pseudo-archaeological claims often exploit genuine mysteries by presenting unsupported conclusions as established facts. Because the prehistoric record contains gaps, it can be tempting to fill them with dramatic narratives involving vanished super-civilizations, extraterrestrial intervention, or forgotten advanced technologies. Such stories attract attention precisely because they promise certainty, where real science often acknowledges uncertainty. The scientific approach is necessarily more cautious. Scholars readily admit when evidence remains incomplete. A newly discovered archaeological site may challenge existing models without immediately replacing them. Ancient DNA may reveal unexpected relationships while raising entirely new questions. This willingness to revise conclusions as evidence changes is fundamental to archaeology, anthropology, and evolutionary science. Perhaps the greatest misconception of all is the belief that prehistoric people are somehow less intelligent than modern humans. The archaeological record repeatedly contradicts this assumption. The people who cross deserts, navigate coastlines, survive Arctic winters, construct watercraft, create cave art, and establish social networks across continents possess cognitive abilities fundamentally comparable to our own. Their technologies differ because their circumstances differ, not because their minds are inferior. Indeed, if a modern person was suddenly placed alone into the landscapes of the late Pleistocene without modern equipment, survival would be extraordinarily unlikely. The knowledge required to recognize edible plants, predict seasonal animal movements, build effective shelters, make reliable stone tools and navigate unfamiliar wilderness, represents an intellectual achievement accumulated through countless generations of careful observation. What survives in the archaeological record suggests that humanity's greatest strength has never been domination through force alone. It has always been the capacity to learn, adapt, cooperate, and pass knowledge forward. These qualities allow small groups of hunter-gatherers to spread across nearly every environment on Earth without the benefit of agriculture, metal tools, writing, or complex machinery. As myths gradually give way to evidence, the story that emerges becomes no less inspiring. The ancient migration is not remarkable because it hides impossible secrets. It is remarkable because ordinary human beings equipped with curiosity, resilience, and shared knowledge accomplish something extraordinary. Their legacy is not confined to buried bones or ancient campsites. It continues living within every society that exists today, setting the stage for the final chapter of this remarkable journey. Although the footsteps of the first great migrations disappeared tens of thousands of years ago, their legacy has never truly faded. It exists quietly beneath every modern nation, every spoken language, every genetic lineage, and every landscape where human communities continue to live. The greatest journey in history did not simply carry people across continents. It reshaped the biology, culture, and future of an entire species in ways that are still unfolding today. Perhaps the most direct evidence lies within the human genome itself. Every cell in the body carries a record of countless generations reaching back through time. Unlike written documents which preserve only a few thousand years of history, DNA contains echoes of migrations stretching back hundreds of thousands of years. Modern genetic research has revealed that every living person ultimately belongs to one remarkably interconnected family tree. This realization has profoundly changed scientific understanding. Earlier generations often imagined humanity divided into clearly separate biological groups that developed largely in isolation. Genetics instead demonstrates continuous movement, repeated interaction, and extensive shared ancestry. Even populations separated by oceans and continents ultimately trace their origins to common ancestors who lived deep in prehistoric Africa. The small genetic differences observed among modern populations largely reflect adaptation to local environments rather than deep biological separation. Skin pigmentation changes gradually, according to long-term exposure to ultraviolet radiation. Certain populations develop increased tolerance for high-altitude conditions where oxygen levels are lower. Others evolve improved resistance to local diseases or the ability to digest particular foods more efficiently. These adaptations are genuine and scientifically measurable, yet they represent only tiny variations within an overwhelmingly shared genetic heritage. One fascinating example involves lactose tolerance. Most mammals lose the ability to digest milk after weaning. However, several human populations independently evolve genetic changes, allowing adults to digest lactose throughout life. These adaptations appear thousands of years after the Great Migrations closely linked to the domestication of cattle and other dairy animals. This demonstrates that human evolution does not stop when prehistoric migration ends. Instead, biological change continues wherever new cultural practices create fresh evolutionary pressures. Ancient DNA has also revealed how inherited genes from Neanderthals and Denisovans continue influencing modern populations. Certain immune system genes originally acquired through interbreeding help modern humans respond to pathogens encountered outside Africa. Some inherited variants affect skin biology, fat metabolism, sleep regulation, or adaptation to cold environments. The remarkable Denisovan-derived EPAS1 gene continues assisting many Tibetan people in living at elevations where oxygen is scarce. These discoveries fundamentally change the meaning of extinction. Although Neanderthal and Denisovan populations eventually disappear, as distinct groups, fragments of their biological heritage survive within billions of people alive today. The ancient migration therefore becomes not only a story of replacement, but also one of integration. Humanity carries part of its lost relatives into the present. Migration shapes more than biology. It influences language in ways that scholars continue exploring. Thousands of languages exist today, yet all almost certainly descend from far older forms of speech that spread and diversified as human populations became separated across continents. Linguists cannot reconstruct the original language spoken by the first migrants, but patterns of language families reveal repeated expansions, isolations, and contacts over thousands of years. Cultural traditions likewise preserve echoes of ancient movement. Similar toolmaking techniques appear across surprisingly distant regions. Shared myths sometimes reflect common ancestral ideas carried long before written history. Ritual practices associated with hunting ancestor remembrance or seasonal change occasionally display striking parallels despite enormous geographical separation. Scholars remain cautious when interpreting such similarities because independent invention is always possible, yet migration undoubtedly contributes to the remarkable interconnectedness of human cultures. Even many diseases reveal traces of ancient journeys. As populations expand into new environments, they encounter unfamiliar parasites, bacteria, and viruses. Genetic adaptations affecting immunity spread through natural selection, while pathogens themselves evolve alongside their human hosts. Modern epidemiology increasingly recognizes that humanity's deep migration history continues influencing patterns of disease susceptibility today. The landscapes shaped by prehistoric migration remain visible as well, although often hidden beneath modern development. Ancient travel corridors become later trade routes. River valleys supporting hunter-gatherers eventually nurture farming villages and then major civilizations. Mountain passes crossed by small Ice Age communities later carry caravans, armies, railways, and highways. Geography continues guiding human movement long after the original migrants have vanished. One particularly striking example is the Fertile Crescent. Long before agriculture emerges, migrating hunter-gatherers repeatedly occupy its valleys and hills. Their familiarity with local plants, animals, and seasonal rhythms lays the foundation for the later agricultural revolution. Similar patterns appear elsewhere where ancient mobility gradually gives way to settled societies without completely erasing earlier traditions. The legacy of migration is equally evident in humanity's remarkable adaptability. Modern people inhabit tropical rainforests, deserts, Arctic tundra, high mountain plateaus, isolated islands, and sprawling megacities. This extraordinary ecological range is unmatched among large mammals. Its origins lie not in recent technological advances alone, but in the behavioral flexibility developed during tens of thousands of years of prehistoric expansion. Perhaps the most important inheritance is psychological rather than biological. Curiosity, cooperation, innovation, and the willingness to explore unfamiliar environments repeatedly distinguish Homo sapiens throughout the migration. These qualities do not disappear once continents are settled. They continue driving later voyages across oceans, scientific exploration, technological invention, and eventually even journeys beyond Earth's atmosphere. Scholars still debate many details of the ancient migration. New fossil discoveries occasionally shift accepted timelines. Improved dating techniques refine archaeological sequences. Ancient DNA continues revealing previously unknown population movements. No single reconstruction is likely to remain unchanged forever, because science advances by incorporating new evidence, rather than protecting old assumptions. Yet amid these ongoing revisions, one conclusion has become increasingly secure. Humanity's global expansion is not the achievement of one exceptional generation or one extraordinary leader. It is the cumulative result of countless ordinary people making practical decisions over tens of thousands of years. Parents search for safer places to raise children. Hunters follow migrating animals. Families adapt to changing climates. Communities share knowledge that helps neighbors survive unfamiliar conditions. History often celebrates dramatic moments, but the greatest migration ever undertaken succeeds through persistence measured in generations. When viewed from this perspective, every modern society becomes part of the same continuing narrative. The boundaries separating nations today are recent inventions compared with the immense timescales of human migration. Beneath differences of language, culture, religion, and politics lies a shared prehistoric journey that ultimately belongs to everyone. The descendants of those first travellers now number in the billions. They inhabit landscapes their ancestors could never have imagined and possess technologies beyond the wildest dreams of the Ice Age. Yet each heartbeat still carries echoes of that ancient movement outward from Africa across deserts, mountains, frozen plains, vanished coastlines, and forgotten worlds. The journey changed humanity forever, and in many ways it is still shaping who we are today. The greatest migration in human history has no monument marking its completion. No ancient inscription records the moment when the final continent is reached. No empire claims credit for its success. Instead, the journey ends so gradually that no single generation realizes it has crossed the threshold into a new age. The descendants of travelers who once walked out of Africa now live across nearly every habitable region on Earth. The migration that began with small bands following rivers and herds has transformed one African species into a global one, forever altering the course of life on this planet. Looking back across this immense span of time, the most remarkable achievement is not simply the distance covered. Countless animals expand their ranges when climates permit. Humanity's story is different because every movement carries accumulated knowledge. A successful hunting strategy learned on one continent becomes the foundation for survival on another. A new way of making clothing allows families to endure colder winters. A better understanding of seasonal plants supports larger communities. Innovation never remains isolated for long. It is preserved, refined, and passed forward until each generation begins its life slightly better prepared than the one before it. This cumulative process becomes the defining characteristic of Homo sapiens. Evolution continues shaping the human body, but culture increasingly shapes survival even faster. A child does not need to rediscover how to make fire, recognize edible plants, or construct shelter. That knowledge already exists within the community. Every generation inherits not only genes but also thousands of years of shared experience. The migration also demonstrates that adaptability often matters more than specialization. Many Ice Age animals become extraordinarily successful within narrow ecological niches. Woolly mammoths flourish on cold grasslands. Giant ground sloths dominate particular environments. Saber-toothed cats evolve powerful hunting strategies suited to specific prey. Yet when climates change rapidly, specialization becomes a weakness. Humans, by contrast, repeatedly alter their diets, technologies, and social structures to match changing conditions. That flexibility explains why Homo sapiens survives environmental transformations that eliminate many larger species. It also explains why descendants of the same ancestral population eventually thrive in Arctic tundra, equatorial forests, mountain plateaus, oceanic islands, deserts, and fertile river valleys. Few species display such ecological versatility. The journey leaves another profound lesson. Humanity never develops in complete isolation. Throughout prehistory, populations separate and reunite repeatedly. They exchange ideas, technologies, and genes. Encounters with Neanderthals and Denisovans permanently reshape the human genome. Neighboring communities share innovations that spread across continents. Even after permanent settlements emerge, trade routes continue linking distant cultures whose ancestors once travelled entirely different paths. Modern political borders often encourage the illusion that human history consists of separate national stories. Deep prehistory tells a different narrative. Rivers ignore borders. Mountain passes connect rather than divide. Coastlines invite movement. The ancestors of today's populations frequently cross landscapes that now belong to many different countries. The prehistoric world is connected by geography long before it is connected by governments. This perspective also changes how civilization itself is understood. Great cities such as Ur, Memphis, Mohenjo-Daro, Anyang, Teotihuacan, and countless others often appear as dramatic beginnings in written history. Yet none arise from empty landscapes. Beneath every civilization lies an older foundation created by thousands of years of migration, environmental adaptation, cultural exchange, and accumulated knowledge. Farmers inherit the observations of hunter-gatherers. Traders follow pathways first explored by seasonal travelers. Builders settle valleys that earlier generations learned to understand through constant movement. One of the most humbling discoveries of modern archaeology is how frequently ancient assumptions require revision. Fossils once thought unique become part of broader populations. New cave discoveries extend occupation dates by thousands of years. Ancient DNA uncovers migrations invisible to traditional excavation. Entire submerged landscapes emerge through underwater research. Every decade reveals details that previous generations could scarcely imagine. This continual refinement reminds us that history is not a finished book. It is an ongoing investigation. Scholars still debate the precise timing of certain migrations. Newly discovered sites may shift accepted chronologies. Unknown branches of the human family tree may yet await discovery beneath unexplored caves or buried sediments. The evidence remains incomplete, but its overall direction grows steadily clearer with every new finding. Perhaps the greatest misconception about ancient migration is the belief that it belongs entirely to the distant past. In reality, movement remains one of the defining characteristics of humanity. Long after the Ice Age ends, people continue crossing mountains, oceans, deserts, and forests. They establish new settlements, exchange languages, develop trade networks, and adapt to unfamiliar worlds. The motives change, technologies improve, and distances increase, but the underlying impulse remains familiar. Today, satellites map the planet in extraordinary detail. Aircraft cross oceans within hours. Spacecraft travel beyond the solar system carrying messages from Earth. Yet these astonishing achievements remain connected to the same qualities that allow small groups of hunter-gatherers to leave Africa hundreds of thousands of years ago. Curiosity encourages exploration. Cooperation makes ambitious journeys possible. Shared knowledge allows each generation to begin where the previous one ends. The ancient migration therefore changes humanity forever, not because it concludes with the occupation of every continent, but because it establishes a pattern that never truly disappears. Every scientific expedition, every voyage across unknown seas, every settlement founded in unfamiliar territory, and every attempt to understand new environments echoes decisions first made beside ancient rivers beneath African skies. The people who begin this journey never know the scale of what they have started. They cannot imagine cities illuminated at night libraries preserving millions of books or spacecraft photographing distant planets. They simply respond to changing seasons, shifting climates, and opportunities beyond the horizon. Yet from those ordinary choices emerges the extraordinary story of our species. What survives in the record suggests that history is rarely shaped by single dramatic moments. More often, it is transformed by countless small decisions repeated across immense stretches of time. Step after step, valley after valley, generation after generation, humanity walks out of one homeland and gradually becomes a global species. Every person alive today carries part of that remarkable inheritance, whether through shared ancestry, inherited genes, ancient traditions, or the enduring human desire to keep exploring what lies beyond the next horizon. Word count 1098. The footsteps have long since disappeared. Wind and rain erase the tracks left beside forgotten rivers. Glaciers melt away. Forests grow where open grasslands once stretched. Coastlines sink beneath rising seas, and mountains slowly weather into dust. The landscapes that witnessed humanity's greatest migration become almost unrecognizable, yet the journey itself is never truly lost. Its memory survives in quieter ways. It survives in stone tools resting beneath layers of earth, in fragments of ancient DNA, preserved within forgotten bones, in pollen buried beneath lake sediments, and in submerged plains hidden beneath modern oceans. Piece by piece, these scattered traces allow the distant past to emerge again, not as legend, but as the patient reconstruction of countless ordinary lives. The people who began this migration leave behind no written names. They build no vast empires. They carve no histories into stone. Their greatest achievement is simply that they endure. They adapt when climates change. They learn when familiar paths disappear. They share knowledge with children who will someday carry it farther still. Every civilization that follows inherits something from them. The first farmers inherit their understanding of seasons. Sailors inherit generations of curiosity about distant horizons. Explorers inherit the confidence that new landscapes can be understood rather than feared. Even modern science reflects the same impulse that once led small groups to walk beyond the edge of familiar country and discover what waited there. Perhaps that is the quiet lesson left by the ancient migration. Human history is not merely a sequence of kingdoms rising and falling. It is also the story of resilient cooperation and the remarkable ability to transform uncertainty into opportunity. The world changes again and again, yet people continue adapting with imagination, patience, and shared experience. Somewhere beneath forests, deserts, fields, and cities, forgotten camps still wait to be discovered. Beneath the waves, ancient coastlines remain hidden in silence. Within our own cells, echoes of long-vanished relatives continue their invisible work. The journey is over, yet its evidence is still unfolding. As the evening grows still, it becomes easier to imagine those distant travellers pausing beside a fire after another day on unfamiliar ground. Above them, the same stars shine across the dark sky. Ahead lies another valley, another river, another horizon that no one in their family has ever seen. They rise with the morning and continue walking. Without knowing it, they are carrying the future of humanity with every step.